Good morning, good afternoon, and good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon. I'm a 3D printing variety streamer here on Twitch. I hope everybody's doing well today. Good morning, Wilk Allen. Hey, Mr. Wizix. Zombie, how's it going? Zombie, I need you to DM me on Discord and send me your address. I cannot send you anything without an address. So I hope everybody's doing well. You'll see there's a little tripod over here. You'll see it's a tripod. It's got this very, very small thing on it. That is the new Tiny 2 that came in yesterday. So we've now got a OBS Bot Tiny 2 is the main camera. This will be the bench camera that's normally right over here. But today I've got it set up right here because we're going to be working on the RatRig right over here. We're not moving the RatRig. It's a beast, and this is just the 300 size, smallest version, and this is a two-person lift. It's too unwieldy to try and move. So we're gonna work on it in place, hopefully without having to take a side panel off. If we do take a side panel off, it'll be just the one. Oh yeah, these Tiny 2s, because I think you picked up a Tiny 2. They are literally tiny. They're cute. They're cute little pocket size thing. Like, there we go. Cute, cute, tiny little pocket size. They're, you sit there and you go, oh, Tiny 2, yay. You don't realize how small those little things are. So good morning, everybody. Hey, Nick, how's it going? Shrimp Father, how's it going? Hope everybody's doing great. Yours is upside down on the ceiling. Well, at some point, the Brio 4K that's up here, which used to be the side one, the one that kept freezing, is sitting somewhere. I'm going to see if it'll work on another computer. But I did pick up the 3-in-1 hub that OBS Bot sells, and it's specifically designed to run 3 of their cameras. It does require a 18-watt USB power to be applied. I've got all of that stuff to provide power. I'm using a 5-meter long USB cable that's rated for the video signals, so that's good. And like I said, at some point, rather than doing it on an arm up here, because if I get rid of the banner, you'll see the other camera up here. I may go ahead and mount it directly to the ceiling, or with a short drop down and do the top mount with another Tiny 2, but they're like $300 a piece. Now, granted, I don't need the full Tiny 2. I could probably just get away with the Tiny 2 Lite, which doesn't have some of the gesture controls, but it also doesn't have the autofocus or the same type of autofocus, stuff like that. But anyhow, we're upgrading. Yeah, and these are 4K 30 frames per second, and if you go 1080, you get 60 frames per second, so definitely good. So yeah, anyhow, we're going to be working on the RatRig over here, and I'm just going to, so it's going to be difficult for me to follow everything because the way my setup is. So normally I'm sitting here and I'm looking at the cameras, and I'll have one screen that has all of the the instructions and everything, so you guys can follow along. Then I'll have chat and everything on the other screen. I'm actually going to have to put the chat window over on the other screen as well, so you guys will see that. Just because otherwise I'm not going to see y'all chatting and I'm going to miss a bunch of the conversation as I try and follow along with the instructions. So bear with me, folks. I promise we'll make it through this. New little setup here, but let me go over to the, let's see, we want to do bench side real fast, and I'll show you this camera's view. We're going to try and do this angled view coming in, and that way it'll let me sit in here and work on things so you can see what I'm doing, hopefully without completely blocking everything. I think this is the best thing that I can do. About the only other thing that I can do would be to set the camera like up in the back corner somewhat and coming down from the back. So we'll see. We'll kind of play through this. We'll try a camera angle, see if that works. If it doesn't, we'll move the camera around and see if we can make things easier to see. Good morning, Eagle of the Dragon. How are you? Hope you're doing well. This is good? Good. Okay, so I've got some coffee. I did stop and pick up some coffee. Go to the browser window. I'm going to have to change the view on the browser. And based on the way that we've got the angle, I'm going to move that over here. A little bit bigger for you all, so it's not going to be eating anything. And then that one, maybe 3D logo. There we go. So we're going to be working on the IDEX today. Thanks for the lurk, zombie. We're going to be working on the RatRig IDEX upgrade today. When we do this, we're also going to do a couple of other things. The Orbiter V2 Smart Sensor, we will be installing these as well as we're going through and doing this. And we also have a RatPack. So before this series is done, we'll also install a RatPack in here and get that going as well. But today we're going to be focusing on the IDEX upgrade. Allow you to do some multi-material printing. Okay. Copy mode. You can do mirror mode. There is automated setup with a camera. That is the CNC or CXC camera from Ember Prototypes that we'll be using for that. We also have Z offset calibration that will be set up with a precision Omron in stock. So lots of stuff going on. We did get parts as part of this kit. I did order the parts directly from RatRig, so I didn't have to print these parts myself. I could have, but right now just trying to get the punk fill. Like I ordered the black ABS from RatRig when I got the RatPack, and they were out of it and it wasn't coming in until like June or July. So I switched over and got Rancid Red. So we'll try out some Rancid Reds. Hey, welcome on in, Lost. How's it going? Hey, T. Moore, how's it going? Sorry about that. Preparations, let's get started. I will tell you this, when I got started last night moving everything out and around so that I will be able to get in here with this setup. But I also went ahead and removed the filament that was in here. That's why the PTFE tube is slightly uncovered, because I had to do that. That'll just make life easier because everything's already cooled down, so I can start working on it straight off this morning. So we're going to go ahead and start our guide for preparation. For the introduction, we're going to loosen the lower set screws. Be careful not to lose it. Do not touch the top set screw. So we're just doing the bottom set screw. This should be 2.5. No, 3 millimeters. We're doing the bottom one, so this would be the lower belt. The top one is for the Y hybrid motors. We're not going to be messing with those at all. We're only messing with the lower or the AB belts or XY belts. So rolled that about 3 times. Loosen the M4 tensioner screw and release the belt. Be sure the screw remains threaded in the tensioner arm. Do not remove it completely. We're going to do that on both sides. Make sure that it remains in there and that our belts are now nice and loose and floppy. Now we're going to start taking some things apart. We're going to remove the M4x10 countersink screw. So this is on the left side here. That's going to allow us to pop our belt loose. Remove the front belt clamp and remove the belt. Repeat the previous steps for the lower belt. Okay. Now this is interesting because we have wires and stuff coming up here. I don't know why they're trying to get us to remove this with these wires still here. Need to, all right, might need to wait on pulling this out until these wires are done. Or let me see, maybe I can snip that zip tie and get these wires free. A little bit further out of the way. There we go. That ought to make it easier to get the belt piece out. There's the belt piece. Put that aside with the screws for that, and the belt pop out. There we go. So there's one belt out. We're going to do the same thing over here on the other side. Take this screw out. Is there a kink to all the upgrades you're doing to the RatRig? Link. Yes, give me 1 second and I'm going to pull this out. There we go. So our belts are now out of the front side. The links that we're doing right now are, this is the doc page that I'm going if you want to pull up the documents and see it a little more clearly on your screen. Yeah, no kink here. It's not that kind of din. Yeah. So next up is remove the M3x35 cap head screws from the back of the tool head and remove the back belt clamp. Okay, these are the long ones that go in through either side. These should be 2.5 millimeter. So these are the ones that go all the way through from each side and tension the belts in the back. Come on, almost. That one's there. This one should be lower. I love super long screws. This is where having a electric screwdriver would be worthwhile. Problem is we normally don't do a lot of super long screws that have to be screwed in like almost the whole way. Normally we have a super long screw that's going through a piece and it's just, 3 or 4 millimeters it's getting screwed in. Yeah, that one's out. We're gonna pull on our belt. Not. Didn't think. Trying to get these belts out, and then also trying to get the green parts to push through. Okay, might be fun. Idea. That did not work. We'll get that out in a second. Velocity Projects 3D has their F1 model on sale on Cults 3D for a couple more hours. Nice. Feel free to throw the link in there. I'm going to go ahead and take off my lighter weight KB3D hoodie because I'm already starting to warm up now that I'm back inside. I'd take Mrs. Dragon and drop her off at the train station today because she's on her way up to DC. Okay. We're going to remove the M3 cap head screws and move the two M335 cap head screws. Move the Toolhead board. Okay, so we're taking the Toolhead board off. Taking off cap head screws. There will be there's a small one. Small one. We're basically going to be just taking the tool head apart and rebuilding it with, I'm going to go ahead and remove the zip ties. We're going to take the tool head apart and rebuild it with new parts because we're going from running 2 belts to 1 belt per tool head. Parts are going to change when we do that. Those. I'm trying to go through and remove all the zip ties. Wants me to remove the tool headboard and move the cap head screws. I did. Okay, it didn't want me to remove the board screw. It wants me to remove this as an entire piece. So I was basically just essentially messing myself up there. All right, let me put one of these screws back in. Now that I know what it's asking me to do. That one in. When at first you don't succeed, read the instructions. 10,000 for 30% off. Okay. Let me add this one back up here. Process. Now what it wants me to do is remove these M3 by 35 screws. Oh, one there, one all the way down here. And these are going down into the lower plate. Out at least. And now it wants me to get these side ones that I'm going to need to use a ball end driver for. One on this side, and these are the ones that are connecting to the standoffs. There's one high, and then there should be one lower one. Almost done. There we go. There we go. That's removed now and loose. Move the hex standoff M3 by 24.5. So it wants me to remove that hex standoff completely. So we have the one in the back that came out, and then it wants the one in the front taken out. The only way you're getting to that is to take your tensioner off. Open that up, and now you can get to this front screw. And there went the tensioner, the spacer. We're trying to get that out. And we'll be putting in a slightly different size spacer. Oh, hey, Mrs. Dragon. Now we're going to take the orbiter off. So remove two M3 by 8 cap screws. We'll take the orbiter itself off. Here we go. Remove the orbiter V2, remove the PTFE tube, remove the M3x16 cap head screws, and the tool head shroud. Okay, so it wants me to take this directly off. Now, one of the things that I am going to do is trace this around, and we're going to undo that motor. So I am going to have to come over on this side just to be able to see. We're going to undo this motor. First off, we're going to turn the printer off because I just realized I was working on this with power on, which is bad. Undo that, and that'll let us take this completely off. The reason we're going to take this completely off is this is an Orbiter 2.0. The plan is to put the Orbiter 2.5 on here, and the new Orbiter 2. Well, the IDEX kit, so for the second tool head, would come with a Orbiter 2.5. My goal is to replace this Orbiter 2 with another Orbiter 2.5 that I got from West 3D that should be in, looks like Monday now. Don't know why. Now it wants us to take our front fan shroud off. I think I much rather would have wanted to take stuff off before doing the belts because now this slides really easily on the belts. Just order of operation, tear your tool head down and then do the belts as a last resort when you have to. That pops off, the shroud pops off. Remove the 4010 axial fan. Okay. So once again, we'll trace that back to where it plugs in and we will unplug that. Set it aside. Good morning, Layers with Lily. How are you? Hope you're doing well. we stopped and got our morning Dunkin' on the way back from dropping Mrs. Dragon off. Why am I upgrading the printer? Chi-Town Deke. I am upgrading the printer. So what I have right now is a RatRig V-Core 4 with the hybrid kit, meaning I've got the two Y motors in the back. So these motors at the top are only driving the Y belt. And when I bought the printer, I was the first one to get one, and the IDEX option wasn't available. So now you could order a printer with the IDEX option now, and they recently came out with the IDEX option as a standalone upgrade kit that you can buy. So I bought that kit. When I bought that kit, it came, so the original printer came with an Orbiter 2. The kit came with a 2.5, which has some slightly different gears in it. My original plan was to buy the Orbiter 2.0 to 2.5 upgrade kit so that both the Toolhead extruders were the same, right? So I ordered it. I did not order that orbiter from RatRig because I didn't realize that it had a different or the upgraded extruder until I got the kit and was looking through it. And then that's when I realized it. So rather than order another orbiter from RatRig in Portugal, I ordered it from a local vendor here in the States, so it gets here quicker. Okay, now it wants us to remove the end stop M3x6 cap head screws. So the end stop is right here. So we'll remove these screws. So why am I upgrading it? I'm upgrading it to IDEX so that we have 2-color or 2-material printing options. There's the other. Sorry about getting my head in the way. I just need to be able to see the screw. And as I'm taking these off, I'm trying to keep the screws together because chances are the screws and everything are going to stay the same. It's just slightly different printed parts that are going to go back on here. For the orbiter 4010 fan and end stop aside, it will be needed later in the guide. Yep. Remove the 4 M2.5x6 countersunk screws. Remove the Rapido Hotend. Okay. So once again, we're going to remove the Rapidos. So we'll go ahead and remove our thermistor wire, and I need a tiny, tiny screwdriver to remove the power wires for the thing. Of course, that leads to other questions. Okay. IDEX is independent dual extrusion. So what that means is we will have 2 different tool heads, and let me scroll up here a bit and I'll actually go over to the full display so you'll get to see chat. Hey Tim, how's it going? So I'm going to scroll up a little bit here. So what does IDEX get us? So IDEX is going to give us 2 actual tool heads on the printer. And what that does is allows you to print in, say, multi-material so that you can do flexible and rigid parts together. You can do water-soluble supports. You could print PLA supports for a PETG part or vice versa, because PLA and PETG does not stick very well together. So you can use those as breakaway supports. You have the ability to do a 2-color swapping print with less waste and things like that, a little bit faster. You have copy mode and mirror mode, so you can print 2 items side by side. So in the same time that you would print one, you're printing 2 without the increase in print time. And you can do that with a copy or a mirror. So yeah, in the copy mode, the 2 tool heads are going same direction. It's kind of like they're staying parallel to one another. where in mirror mode they're going opposite directions of each other. So you'll probably get more counter vibrations one way versus the other. To facilitate this, the thing that you have to do is you really have to have things dialed in so that your two print heads properly align when you're trying to do these dual material or dual color prints so that you don't have what would appear like a layer shift, right? You also need to have Z in-stop calibration as well. So this one is aligning the tool heads in the X and the Y. And then you've got the Z offset calibration to make sure that they're at the same height or that it can adjust for the height so that as you're printing a layer, you're printing a good layer. That's kind of where we're at. And all of that alignment stuff is the same thing with like a stealth changer, a tap changer, the black box, the E3D 5-head tool changer, the Prusa XL, any other IDEX. You're trying to make sure that the plastic that is coming out of the printer is all coming out in the same location. Where was that one? Okay, here, move that. What I'm doing is I'm removing the heater wires for the Rapido right now so that when we go to take the tool head out, it's not just dangling from these two thin wires. So we'll take these 4 screws out. These should be 2.0. Oh, 1.5 driver. E. You? These were put in with some Loctite. That's why it's so much fun, and I'm trying hard not to strip these, which I think I just stripped that one. Three of the 4 out, and one of them feels like I may have stripped it. Okay. Yep, that one's stripped. So off to our iFixit kit, and let's see if we can use a Torx bit to get this out. And that's going to be a no. Uh-oh. Uh-oh. All right. Anybody have an idea of a good way of getting a stripped bit out, because the only thing I can think of is drilling the head out, and that's kind of scary. We're going to hope that we can work around it. Move that, undo the 4 and 3x40 countersink screws. Which one? These are the ones. Okay, these are the M3x40s up front here. The downside is it's going into this printed part, and that printed part has to be swapped out. Dang it. Oh. Okay. We're going to have to figure out how to get this screw out, which means I may have to drill it out. Fan shroud, remove the other one to the front. And this come out the, let's see. We can get this out without messing up the wires. I think we can if I take the whole thing off. I think is what we're getting right. That pull the fan. Okay. Move the two M3x6 low head screws that are holding the beacon in place. Wants us to remove our beacon from underneath here. The beacon low profile. That. Just going to remove the cable. There's our beacon probe. Nice simple little probe. And yeah, let me switch over to the other screen again. it's a hex bit going into the actual top. So it's going through a metal plate and into the top of the hot end. And did it tell me to take the... All right, so here's the thing. It did not tell me to take the entire thing off the carriage. I'm going to do that because that's going to be my only way of getting this off. So we will take this off of the carriage. Still need to get the belt out of there at some point. Comes out, the belt comes out. Completely off as well. Those pieces are out. We're going to take this completely off. Because once again, that's going to allow me to have some room so that I should be able to rotate this around away from the wires there. That's the thing that's worrying me. Maybe. Maybe not. Dang it. Right, we're so close. And the wire in question is our thermistor wire. Take that off. Can we get the thermistor wire undone and out of there? Yeah, because my fear is I've rounded that. Oh, there we go. Got it off. So good. Now it wants us to remove all of the screws on the X linear rail because we need to add the other MGN12C carriage, which is great because now I need to find the other MGN12C. I thought I had it, but the carriage I thought it is not. What did we do with the MGN12C? Does anybody remember? I mean, chances are I put it somewhere and I've moved it 8 times, so it's kind of a laughable thing to say, hey, do you guys remember where I put that carriage at? That may actually stop us if I cannot find that carriage. MGN12C. Because I have MGN12 carriages, but they're not C, they're H. And I know the carriage came with it. Hey, Papa Bear Yell Nats, how's it going? So the screw in question here is this one, and it's whoop, where am I going? It's put in with Loctite, and I have now rounded over the hex head in it, trying to loosen it, so it's not coming out. Might as well go ahead and just put the others back in, because the only way I'm getting it out now is if I drill it out, and I don't really want to do that. We'll have to do some shenanigans when we go to put this back together. And I did use blue Loctite. I did not use red Loctite, because otherwise I would have gotten none of these out. This is a 300, so it's 300 by 300 by 300. There are RatRig 400s, there's RatRig 500s, but this right here is the 300 variant. And right now what I'm trying to do is find the MGN 12C rail that came with this kit so when you get the initial kit, it comes with both carriages, just in case you were buying it and going IDEX from moment of go. Which I couldn't because it physically wasn't available when I ordered this kit. So we built it as hybrid, and you have to take that extra carriage off, otherwise it just throws a bunch of things off. And now you have to find the carriage that you may have taken off months ago so that you can put it back in. And you would think that I would have laid it like next to the printer, but you would be wrong in that regard, apparently, because I am apparently wrong. I've dug around in here three times, so let me dig around again and give it one more look. Nope, nope, nope. Didn't sit it in the printer, didn't sit it under the printer. Oh, orbital, smart orbiter tool sensor. Oh, cool. One of those already. Like maybe I was planning. Ooh, hey, there you go. I think I found the box that might have the old stuff from this build, which would have some of the parts that we may need, like that's going to give us the spacer that we need for the rail to put it back in there. Hey, whoa. Look, 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 there we go. That's what we're looking for right there. Awesome sauce. And it's not that we didn't have a little bit of extra stuff. So yeah, we had plenty of extras in here. All right, we'll set that over there. Set that over there. We will need the rail spacers for this. so that we can get our rails spaced out correctly again. Okay. And we're going to take this rail off and slide the second carriage in. Now let me check and see if this was pre-lubricated or if we lubricated it before we put it away for storage. Because it would have been on there. Bone dry. Bone dry. So we're going to need to lubricate this. I'm going to do that right over here off stream or off screen real fast. I know Liz likes to see me lubricate my balls and rails, but right now we're just trying to keep some progress going. And I would much rather have this ready to go before we take that rail off. So we've got our Mobilux. Grab me a nitrile glove real fast. Yeah, it looks a lot larger. Now here's the thing. This is a true 300 by 300 by 300. A Voron, which is what most of us are going to be comparing it to, is a 300 by 300 by what, like 250, 270. It is much bigger than a Voron size-wise for the print volume. And part of that is the spool holders are down here on the sides. So there's plenty of room all the way around the sides of the printer. And you'll see that a little bit later when we go and install the RatPack as well, as part of this line of upgrades. Because the RatPack will be a internal HEPA and activated charcoal filter. And there is also talk of there being a dedicated RatRig fully supported MMU option. And I believe that option was being talked about as being another fully internal item. So I do not know how that would work out. Okay. Wipe that off. What I'm going to do is make sure that all of this stuff is kind of pushed to the back. Belts are out of the way. Because once again, we're going to have to go in here and remove all of the, well, not remove, but loosen all of the screws so we can lift this up and add in the other carriage. And then we'll have to figure out our spacing and everything all over again. I think these are hammerhead nuts in here. and they are. There's our rail off. What I'm going to do is grab our new rail and flip this over and guide this rail or this carriage onto the rail. So we don't lose any balls. Let me put it over my pad here. No balls were lost in that operation. We now have our carriages side by side again. Going to set that back down in there. Use our rail guides to get everything guided into place. Do that all the time. Remove a thing thinking I'll put it in a better place. Only, yeah. Well, in this case, luckily, as soon as I reached down, I was like, what is in this box that's shoved up underneath the bottom of the printer? And as soon as I pulled it out, I saw a RatRig bag, and I was like, that's the box. It's all RatRig down there. So, like, I've got a box that's ready to go out to the shed that has all the superfluous or extraneous stuff for the Milo, right? So it's got the 1, 2, 3 blocks that came with the Milo, the power cables, and all the tools that you need for a milling machine, right? And then I've got a setup over here. So these are all the these are the motor cables, some other parts and stuff, and the brain box for the RatRig mill. And this is all stuff I did not want to even start to assemble yet, because the one thing I'm missing for that mill is the spindle. And they were like, well, we can send you the 1.5 spindle. And I'm like, but I paid for the 2 kilowatt spindle. Why would I go with a smaller spindle if I've already paid for the larger spindle? Okay. There's our screwdriver. I'm going to try and align the gap here as best I can by eyesight. And install the linear rail back on the gantry extrusion. Fasten the marked M3x8 screws starting from one side. So here's the thing. You can start from the middle and work your way out, or you can start from one side and work your way all the way over. Do not start at the ends and work your way inside. You will wind up with a rail that does this. If you start at one side and go all the way over, anything that's any type of rise or run or decrease will go the full length. If you start in the middle and move out, it's moving all of that stress to the side versus to the inside. So I'm going to start over here on the side. So what I'm going to do is grab this, pull it closer to the side. Once again, make sure that I am about even side to side. Just looking at the gaps. And it tells me to go one side to the other, so what I'm going to do. And these are hammerheads, so you see me loosen them some and then retighten them. because of the way I loosened them, if I just go through and tighten them, chances are they're not spinning, they're just tightening straight up in the gap. So by loosening some more before I go to tighten, it should tighten those up appropriately. Come on, give me my. Now I'm seeing a little bit of darkness or discoloration on the rail itself. And the concerning part for that is this rail starting to rust or not? Or is this just some type of goop that's on top? I'm not scraping it off with my finger, which tells me what I'd really like to do is get a little bit of emery cloth and go over the top and then oil this down. But I don't have any emery cloth. But I will put a little bit of oil on here and just wipe down the rail a little bit to give it a little bit of a coating. And I just use a 3-in-1 PTFE lubricant. And once again, this, oh, hey, Chi-Town Deke, thanks for the cheered bits. This has nothing whatsoever to do with lubricating the rail to make the carriages ride easier. This is lubricating the rail to give it a little coating to prevent any rust. So what I'm doing here is not meant to provide lubrication. It's more of just a thin film of oil on a steel surface to prevent any chance for rusting. And I would suggest doing this periodically to your machines as part of your routine maintenance. Just look at them. And if it looks like you're starting to get any type of rust or dark patches, then give it a little bit of love with some light machine oil, some PTFE lubricant like I'm doing here, and just give it a coating, right? If you use firearms, you know, a little bit of gun oil, if you have some, will go a long way there. My future streaming room is full of boxes unfinished, not started or parts for future projects. Yeah, so I've got plenty of finished projects up here. But what you don't always get to see sometimes is all of the unfinished, partially finished projects that are laid all over the floor. Hence why I tripped and broke my foot on the let me see where I'm at here. On the positron case. Okay, so we've got the linear rail back on. Do not over tighten the screws as it can cause the rail to bind. We're good. Now it says continue to the RatRig V-Core Toolhead IDEX. If you click on that, it takes you to a different page. don't click that link. Just scroll down and hey, here's section 2 for the IDEX. Start the guide. Now what we're going to do is we're going to start rebuilding parts. And what you're going to see is like these parts slightly different. And so we're going to have to go through and do some work here on the bench to do some heat press inserts. So what I'm going to do is move a couple of things around so that I can get my heat press insert up here, or my tool up here. What I was trying to use, or the language I was going to use. That goes there. My heat press tool is over here. And I've disconnected my power so I didn't trip over it. So let me grab that and get it plugged back in. Unplug that, plug this in. Remind me that I've got a power cord there. Don't need that reminder. Okay, so this is going to start heating up. We're going to need some parts. Let me come over here. There we go. Not that far. I want to see that mess. So we got parts. And we're going to need 2 of the fan shroudy pieces to start with. And we'll just get into some more as we go. Now, there should be heat press inserts in the hardware kit. Hardware pack. So, we see what we got here. There are some heat press inserts. M3 by 4 by 4 by 6. Okay. Use these because we need 16 of them. See what we've got. We need some extras. They may be a little bit different size, but we'll use some of ours if we need some. Or we'll root around in the box because I'm pretty sure in that plethora of spares we'll have them. Toolhead 0, Toolhead 1. The difference here is primarily in the back of them. I'll kind of show that off here. And where the belts are going to go. And it wants us to remove the anti-gravity assistance device. I love that term. We're going to remove the AGAD. This is called print and place supports. And we're looking for this piece. And I'm going to say they've already done it. So there would have been print and place supports here and down here because this would have printed in this orientation. Those have already been removed for us. And same thing here. There would have been print and place supports here. Those have been removed. And you can tell because that's a little bit of a sag for a bridge, and same thing down here in this groove. There's a little bit of a sag and you can see the bridging. If I can get some, there we go, some light on it. So that part's already been done for both of these sections. And now we're going to need to install some heat press sensors. So 4 down here, the 2 in the down in the top, and 1 in from the side. So let's go ahead and get these started. Now I'm having to tilt this slightly so I can get it in there without melting back plastic. And then I'll quickly grab one of my whatchamacallit, tweezers, and use that to make sure that it's getting in there flush. We just warm it up, we get it close, and then we use our piece to make sure it's flush. And that's so that it's flush and not down at an angle. Because if it's at an angle, you're going to have issues getting your part or your screws to line up. Because remember, these are like M3 by 35 or 40 screws going through a big, long cooling fan. So we get it close, press it the last bit of the way with the back side of our tweezers. Make sure it's nice and flush. And then the front sides get a little bit easier. Okay, there's those 4. We're going to do the 2 on the top, and then I believe it's 1 in the side. I'll have to double check the 1 on the side. Yes, so this is basically a keyback. There is a version with a, I'll say, less expensive form of a keyback, and it works just as well. But it just, well, I say it works just as well. It doesn't have as much springiness pulling it back. So I think if these things, it's not saying that these get embedded down in there. It just kind of looks or feels like it might. Like they may need to be pushed deeper, but I'm going to resist that urge. But yes, it's a keyback, and the reason you would use a full keyback instead, there is a lighter tension one. You will use this heavier duty keyback like you would use in the switch wires, is because there is an option for a head on here to be able to mount a Dremel tool. So you'd want to have the ability to work with additional weight. So I'm going to pop this up so I can make sure and zoom in, maybe or maybe not. And play this. every once in a while on these embedded pages, I have to like, we'll say re-click to get the pictures to come up, and that one just does not look like it's going to come up. Dang it. Let me get my eyes in here. So it's wanting me to put one in here on this side. That's where I'm going to put it. And you may see that this wobbles a bit. The support underneath, so the upright piece, a little bit more heat. Okay. So this upright piece that has the linear rail on it, it comes down and it has these support legs that then the top cover goes on. These support legs have cracks across them. I need to reprint at least the lower base. I just still haven't yet. Okay, so those are done on this part. We need to grab the other part. And this is an old part, so we'll just toss that to the side. Do the same thing here. So 4 around the fan, 2 on the top, and then 1 in on the side. Oh, and those of you that were on stream Thursday, yeah, so yesterday I was printing the, we'll call them the standoff spacers for the Ace Pro or the Anycubic printer. And I was hearing this squeak and going, why is it squeaking so bad? Well, that's when I decided to go look up. You know, I thought the color of that 3DO filament was carbon gray. Yeah, it's gray with 15% carbon. The Anycubic does not have hardened extruder gears or a hardened nozzle. So it may somewhat be past a 0.4 nozzle right now. I did stop the print when it was about that high, so it didn't run a full print, which would have been almost a day of running and chewing on 300 grams of carbon fiber. Hey sis, how's it going? Welcome on in. Thank you for the resubscribe for 18 months. I appreciate it, sis. So long story short, I did go and switch over to black. Just straight black ASA. And I got it printed. However, when I went to bed last night, something just said, hey, check that printer. You knew you might not have enough filament to make it. So I had to come upstairs. I looked, sure enough, the printer had paused because it needed filament. So I swapped in another spool of black ASA and finished out the parts. and I got the result I was expecting. And if I can figure out where I placed said parts at again. What did I do? Oh. Can you see where the filament swap was? Yep. Right there's where the filament swap was. So this was cooler than this when it went down, and we didn't get good layer adhesion. I can put my entire fingernail in there. So this side's even worse. So yeah, we'll be reprinting these, and I think I did find another. What was that? It was a. I think it's Galaxy Dark Gray. So we'll use that. Okay. Ow. Okay. So we got both of these done. 6 from the top, 1 from the side on both of those. Next, we'll need our fan shrouds. So there's 1 and a 2. So we've got our 2 fan shroud pieces. We're going to need what? 10 M3 and 2 M4. Okay, 10 M3 and 2 M4. Okay, all of those were M3. Good. So we're having to do 10 M3s. Hey, that's not so the front of both and the side, that looking like a completely different 2 sides. Is that just not looking like a here? Let me go full screen for you. So this one here, I wish I could blow it up, but it tells me, no. I don't know why. But this looks like a completely different geometry. Maybe, maybe not. Maybe it's just the angle that makes it look weird. Okay, I don't know. We're gonna put in our heat press inserts. These are gonna once again be the M3s. And then the fun thing is we need to switch over to M4s, which will be great because, well, that means we got to let this cool down so we can get the M4s going. Gotta let it cool down, swap over to the M4s. Well, I guess we don't necessarily have to. We can just, I mean, M4 is bigger than M3, right? So the M3 will fit inside the M4. It just won't be a tight, snug fit. So we'll have to continue to use our flat surface trick to make sure that they finish off flat on the face, which is what I'm doing here with the side of my workbench, which is metal and makes a pretty darn good metal heat sink. Try and whip the heat out of the part faster. All of the parts here for the RatRig, once again, these are the parts that came with the kit that I ordered. You have to pay extra to get the parts from RatRig, and I have to print them yourself. But I wanted to evaluate what you get if you do that, right? So that's why I did it. I do have the capability. I could have printed the parts right there. But part of what I'm doing here is evaluating the fit, finish, and print quality of the parts that you get from RatRig, which are printed on their RatRigs in their shop. So okay, so there's that one, this one with the M3s, and then we'll have to come back and do the M4. And so far, these are really, really good. Hey, Turtle Crawler, how's it going? I saw there's something new out at KB3D and Fabrico. Feel free to talk about anything. I think it was you. Too many things going on in life right now. Hey, sis, have you gotten your shirt in yet? I still haven't gotten mine. It says it's supposed to arrive today, but it doesn't say that. So it says it's supposed to arrive today, but it's not saying that it's out for delivery, if that makes any sense to you. Because it doesn't to me. But UPS and FedEx have lied. I mean, have changed shipping times on me a lot lately. Like you pay for like 3-day shipping, and then they go, "Oh no, winter storm warning," and I'm like, "You're putting it on a plane and flying it across the U.S. Why are you telling me that? Like, were you grounded? Because I don't remember hearing anything about planes being grounded in Oregon." Okay, one more over here. Okay, now those were all the M3. Now it says a pair of M4s. I'm assuming front lower there and the front mid there. These were all M3s. There were no other heat press inserts in this bag. Let me check any of the other bags. Oop, some in the other bag. Some in the other bag. 4 by 5.8 by 6.3. Sure. Two of a kind. Yeah, the hard part there is trying to get enough heat to do the heat transfer to be able to get the part in because you don't have direct contact. That went in. That would be the good reason to switch over to the M4, but just got to let it set a little bit. Yeah. Okay, so the M4s are in the side there. So those are done. Then we'll have our upright. Here's one. There's another one. And these are going to take M3 heat set inserts. I only have 3 left there, but look, there's a whole nother set of them. So we've got more. So we need 8. I've got 3, so we need about 5 more. And which side are these going? This side. And this would be the ones that the board will fit on. And this would be one of the things where I'd wish they would go through and say, like, do all of your M3 inserts and make sure that the one that has M3 and M4 would be at the very end so that you would switch, because now we would have switched over to our M4 to do the last part and then had to switch back to an M3, which means I would have had to let everything cool down again to swap a piece of tooling out to switch over to M3 again. Order of operations and efficiency. I'm going to set these down there because I'm running out of places to set stuff. Ugh. We'll swap back over so you guys can see more of what I'm doing. You've worked aviation cargo? Yeah. Fired by desk lamps from the 70s. Yeah, it looks really cool. Yeah, I have tracking numbers. Frax was a fun little project. I need to update the GitHub with those vendor links soon. Yep. Yeah, I'll talk to Chris and see if I can't get one shipped over to me. He needs to send me the panels for black stack. I got everything in there, but she's showing her bones still. And yeah, that's the thing, Eagle, is I have tracking numbers. That's where I know that a part that I ordered on Monday and paid for 3 days shipping is going to be here the following Monday because of winter storms. And because they use winter storms, it allows them to get out of not making the delivery window because it's an act of nature. Okay. That's good. And what's next? Now we've got a few more, 10 more that'll go in the ducts. Okay, the ducts. Here from the top there. Be careful. Once again, you want these straight, but you also, these are kind of center walls on the ducts, so you don't want to smash your duct, and then you'll be reprinting a part. Yeah, my shirts are supposed to be here today, but it seemed like they've been sitting in Butner for 2 or 3 days. I'm like, hmm. So we'll see. We'll check later in the stream and see what's going on. Like I'm hearing a truck, so there might be a UPS thing being delivered right now. Okay, so now we're going to take this, we're going to flip it over so that the vents are up, and we need to do the two here and two here in the back. So this is going to be the mount for our, one of these is going to be the mount for the beacon. One's going to be the screw bolts coming down through the fan to hold everything in place. This should be the beacon right here. Because the duct holes are going to be facing down towards the print, not up and away from the print. Yeah, it kind of reminds me of the standard desk lamp, back in the day. And it's pretty cool because it can stay mounted out of the way on the side of your bench, and you can swing arm it over where you need it and still get that straight up and down motion, so that's good. Okay. Hey Pezliz, how's it going? Hey Evil Diesel, what's up? Evil Diesel's in the house. He lives. He lives. He has the base parts of the KB3D Death Racer printing right now. I need to start on the base parts of the one that Mrs. Dragon has told me I'm going to build for her. And then I've got some custom parts we'll be doing for KB3D that we'll be printing off on the black box. So, yeah, it's going to be fun. Still need to do a drag racer. Okay. Those are done. Is that all of them? No. Dang it. More parts. These are the belt clamper damper things, and I'm wondering if these are the same as the other ones. Yep, these are the same thing, same length and all. So I'm going to hold these as spares in reserve and just use the old ones. Like these ones didn't get the whatchamacallit, the brims pulled off of them. We'll hold those there and we will reuse the two that we already have that have the heat sets in them. Save us just a tad bit of work. Yep. Get rid of the sacrificial layers. Those are done. And tool plate. 4 M3x6 countersunk screws with applied thread locker. All right, so that sounds like we're done here. So I'm going to remove this, unplug it from there. We'll scoot this back out of the way so I don't trip on it and damage my person. Now I got to find the little plastic piece that I just flipped around. Where did that? All right, well, we'll have to find that. So basically my TS101 here, I broke the plastic piece around the back side of it. I need to find it at some point and glue it back on, but For now, I'm going to set this out of the way so I don't burn myself. As we know me, I will. Okay. Yeah. Well, the KB3D announcement, had to go check it out. Definitely. Um, Working on everything that I shouldn't be. Well, it's because the printers are all running. What are you working on that you shouldn't be? Brewing up ideas for Kalon's birthday. Totally want to run a D&D live action scavenger escape room adventure. Okay. Sounds fun. So I have a feeling that I'm going to need that piece and some of the other pieces in here. So we'll just dump that out for now, because why not? And there were some countersunk M3x6 with thread locker. Yes. So we got 4 of these. So we'll add this part in there. And remember, this is basically, well, this is going to be Toolhead 0. Toolhead 0 is this one. We will re-add this. I think I may have to wait and get the fan shroud on this one first, figure out which fan shroud goes on it so I can get that installed. D0 should be the left carriage on the X-rail looking from the front of the machine. Pay attention to the orientation. The big fan piece goes towards the back. Now we're going to need, this goes on there with 4 screws that we pulled off before. So I've got those 4 right here. We're going to need the fan shroud. So one of these shrouds, I think they're both the same. Don't see anything different about either one of these. So these are the same. And we need this part with the lower belt opening. So this is the one we're going to be looking for. M3x8 and 2 M3x16. Okay. We're going to join these two together. Join the 2 assemblies together, ensuring they are flush. 2 M3x16 cap head screws. Okay. Go like that. We're coming in from the back side here and into the lower 2 M3 heat set inserts. And we should have pulled M3x16s out. Those are the 4 for that. I'm just looking at what I've got here to not seeing. So we'll M3x16. And like I said, if we need to, I've got plenty of spare screws and stuff down on the other side. We'll just have to go and root around. Okay, screws coming in from here. It's one nice big solid piece. On the M3 by 8 cap head screw is going to come in from the front in this gap right here. That was a M3 by 8. Don't over tighten the screws because you will damage the parts. Yep. Especially since the M3 by 8 is, did we not? Let me jump back here. Oh, I missed one. There should have been one right here. So we're going to have to take this other one apart because I just screwed that one into nothing. So we'll need to bring our heat set press back over here and add in 2 more heat inserts. I missed one. Okay, so we're going to do that back over here. We've got here. Going to go over there. Do it over to the side. There. Got room. Grab the heat press inserter. Voila. Hey, thanks for the resubscribe, Diesel. Appreciate it, my dude. You have a few commissions to finish? Yeah. Did you find that part that you needed to do for the DM? Okay. What I'm going to do is just put this over here just in case I have to get after it again. Remind me not to kill myself. Okay. Give that a couple seconds. Hi, Train. Hey, Pezliz. Thank you for the gigantified emote. Chewy, how are you doing? Tier 1 subscribe for 21 months. Appreciate it, my dude. We're sitting here with some different camera angles today. Exactly, Diesel. If something happened to me, your daughter would have to start going to D&D on Friday nights again. Well, if it's huge, give me, I mean, we 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 got a 300 cube printer right here. I got a 350. I mean, I can do big. Let me know. All right, that's cooled a little bit. We're gonna go ahead and reassemble this. By 16, 3 by 16. Once again, don't really yank and crank down on these because it will lead to bad days. Ripped out heat press inserts, and then you're reprinting parts, trying to recover heat inserts. Leads to bad days all the way around. Huge as far as resin, need to clean the file up anyway. Oof. Yeah, you do. Okay, so that's there. Me move forward in time now that we got the one that we missed. So we're installing that, putting these two parts together. 4028 cooling fan, remove the 4 rubber spacers on the 4028 cooling fan. 4028 cooling fan is still over there for Toolhead 1. And yeah, we can undo that. Maybe. Push down the right piece. Yep, here we go. 4028 cooling fan. Rubber spacers. Been de-rubberized. No rubber gasket spacers. I'll prepare the Toolhead fan grill. This piece. These pieces. Okay. And one with the left-hand side. We'll need a few screws, which will be, what size screws do we need? We'll need M4 by 10 countersunk. This is the M4. Yep, M4. Yep. So the M4 by 10 countersunk. 3 M3 by 35. Tap head screws. 1, 2, 3. 2 M3 by 40 countersink screws. Here's those two. And so we have all the parts out here and our screws out there. Back part and duct subassembly, 4028 part cooling fan. Should blow air towards the cooling duct. Point the fan wires to this side. Okay. Fan wires out the left. We're looking for direction of airflow. Why would we bother putting airflow directionality on? That's okay. We know where the airflow. Normally the airflow comes out the side that has the sticker on it. So the sticker is going to go face down, and our wires are coming out the left side. Okay. Okay. This is going to go up from behind on the tool head with M3 by 35s. Great. Hold that thought. Front shroud goes on. That's the part I'm going to need. Is this needs to go around this in such a way that we don't hang on wires. I'm going to try and finagle this on here without damaging wires. Why? This shroud is so incredibly tight around there too. Here we go. Okay, so we've now got that in there, or around there, so we'll be able to insert everything nicely. I'm going to go ahead and install this back on the left carriage with my tiny little M3 by 6mm screws. Bring you over this way again. We're going to be going on to this one. The front fan shroud is just going to sit a little loose for right now. Have Loctite on them. I'm just giving them kind of about an eighth turn of an ugga-dugga on them. We've got the plate. We have this mounted. Normally we would have this mounted first, and then we'd add the hot end. We have the hot end on there. Let me go ahead and pop the stock back on the hot end while I can. And also, this hot end has a 0.6 nozzle. I have to remember that because I either need to put a 0.6 over here or swap them both over to a 0.4, which I may wind up doing that. Okay, so now that we did that, we need to come back here. This is going to go on with the two M5 or M335 countersunk screws. So once again, our fan is going to sit on here like this with our wires coming off to the left. We're going to basically slide this up and under from the back. And M3 by 35s go down through the front two holes right now. And these are countersunk. When you see me wiggle it, I'm just making sure that things are lining up. If you start to feel too much resistance, give it a little bit of a wiggle, and it should help clear that up and make sure that things are properly aligned. Once again, snug, not ugga-dugged to death. Now that front fan shroud goes in, and we're going to use two M3x40 countersunk screws. Two M3x40 countersunk screws. Let me step back here for a second. M3x35 cap head screws and two M3x40. Now this talks about two M3x35 countersink screws. So I just put in two M3x40 countersinks because it didn't tell me to do M3 or pull M3x35 out. So hopefully I didn't just bust that part by driving a screw that was 5 millimeters longer than it should have been. Pull one side out. Here's a 35. This side out. Grab the other 35. Okay. Now we'll be putting M3x40 countersinks in the front. Okay. Yeah, it is a good thing he's a DM. Means he can afford it. So M2x35 cap head screws. So two of them. These are going to go on the back side. So there's a slight recess here. That slight recess. Care not to over tighten, avoid using a ball head. I think the recess is an alignment tool for when we put the rear panel on. So it'll go like this. There we go. Next up is belt. Insert the belt in the designated slot and ensure the belt end is fed from behind the screw. Okay, so the front left upper belt needs to go in and around the screw. Okay. And we're going to use one of our belt clamps. We will grab new ones out of the IDEX kit just because. Make sure that we've got newer ones. I know one of the other belt clips had broken. That's why I'm trying to get a new one out of the kit. It'll be our M4 screw when we get there. And our belt, once again, we've got a little bit of a bend and curve in it now, so that might make it easier. We're going in and around that screw that's in there. In and around. So we may cheat a little bit. We're going to take this screw out. We're going to shove our belt in the opening, put the screw back in, which might make it a tad bit easier. So put belt in opening, put screw down in, make sure belt can't get pulled out by the screw, or means it went around the screw. Tighten the screw back in. And we've now got this routed around the belt. Make sure pull it forward to where it's right at there's a little indent on the side. So we're basically pulling it forward so it lines up with the indent in the side is what we're doing. So we pulled that forward, we laid it into the indent. The belt teeth must be facing the front of the machine. Belt teeth are facing the front. We're going to take our piece here and we're going to lever it in. So this side has the grooves for the belt. That's going to go into the belt teeth that are right here. Where I said we want to make sure that this lines up with that groove all the way to the front so everything lines up. Take this and get it in there. Pull it forward. Put in our M4 screw. Probably not going to use the screw that I have, or the driver that I have in my hand, because that would be too advantageous to me. Or does it? It does. Oh, no, it wouldn't have. Because I had a 2.0 in my hand and it needs a 2.5. There we go. So we'll tighten that down. And this is now captured and is going nowhere. So one side of the belt is now installed. Hey, Hutch's Makerspace, how's it going? Hey, Tugboat, welcome in. Now on the other side, we're going to feed the belt inside the slot on the back part of the tool head. Leave 10 to 20 millimeters of the belt tip extending out to allow for easy manipulation during assembly. So shove it through and leave a little bit out. Okay. M3 by 35 cap head screw. We got one of those. We'll need one of these little, need a little sled, the one that has the heat press insert into it. M3 by 35 screw. And the belt is going into the back side. And top belt, right? Yes. So, okay, that's why it's looking from the back. So this belt is going to pass through the backside. This is going to come in on top of the belt. And then we're going to use the screw from this side to pull this in, which, because that's a sloping ramp, will squish down on the belt. So that, my friends, is what we're going to be doing here. When it comes through, there should be a little bit of excess belt out the front side here. This might be, give me 1 second, and I will pop you guys over here to see this, hopefully. This is what I'm looking at. So the belt sticking through just a, whoop, sorry. Darn thing's adjusting on. So the belt is sticking out just a little bit. The piece inside or the piece over here, I'm not going to be able to do it with this one because it's going to move around on me. I would have to move the camera. So this piece is going to go into that back and wedge forward the belt. And then this comes in from this side and pulls that wedge forward. All right, folks, bear with me 1 second. I'm looking at this and I'm like, looking from the back side, the belt comes in from the left to the right. That piece goes in. Ain't my life sometimes. I put in the wrong, I've got a wrong part in here. Push this out and see. So the fan duct is wrong. Great thing about that is I got to take everything back apart in order to put the right one on there because I put the wrong one on there to start with. Fabulous. The issue is going to be the M3 by 8 screw that comes from the front. That's why I've got to take everything apart to get to it. Because I can take these out, I can take the two underneath out from the back, but the M3x8 in the front, I believe, is going to be blocked by the tool head being in there. Let me see if I can get. Where's that at? Yeah, I'm not going to be able to get the angle, so I'm going to have to take the whole thing apart. Yay. Go on, Hutch. Welcome on in. Hutch's Makerspace. We are trying to get this put back together, and when you mess up one piece, it winds up being an even larger or bigger issue. Like, why is that taking so long? It's because of the other screw. Take that out. This comes out easier. Okay. We're gonna have to take fan off the back. So I'm just going to assemble this one together now. That one over there out of the way. One of these. I'm trying to do this off screen real fast just to make it happen faster, but by 8, and I need M3 by 16 of those. Yeah, I hope you guys are doing good today, Tugboat and Hutch. We've been trying to work around the fact that I stripped one of the screws on this tool head, so I can't take the tool head off. That's why this is a little bit more of a pain in the tuchus at the moment. We're going to need I'll need these again. So we're going to slide this in from the back. Sort of like there we go. Those line up. I'll go down the front, holding this front fan shroud in place. Other one is our other countersunk. We're going to take our belt and put it in there, then put this down, and that would have just captured the belt in there for us. We will make sure that this is kind of lined up, pulled tight. Grab our belt clip, slide it in there, tighten the M4 screw up. Belt clip in there, tighten the M4 screw up. So this belt's taut. Okay, now its complementary belt in the back is now going to slide through the back here. Come out that front side just a little bit like we showed before. Take our doodabber here. This is going to get pulled this way, and as it does, it's going to compress that belt forward to hold that belt in place. And that compressive force is going to be done with a M3 by 35 cap head screw coming from the opposite side here. Sorry for having my arm in the way there. Trying to keep everything lined up and screw in a 35 millimeter long screw. Yeah, I hope everybody's doing well. The new merch is here. We've got light coffee mugs. We've got dark mode coffee mugs, various sizes in both. I believe the dark mode is 12 and 15 ounce. Light mode is 12, 15, and 20 ounce. We've got water bottles, which are also nice to have. Those are 20 ounce water bottles. They work really well. You want to make sure that you feel that getting pulled in so that you know that that belt's getting pushed down tight in there. Here we go. That belt's not completely taut because we still need to tension our belts, but that'll come later. Cut the excess belt? Sure, we've done that. Now, pop in the little pre-cut piece of PTFE tube and use your 4 M2.5 by 6 countersunk screws. And we're going to put our hot end in. Yep, it's there. Silicone sock, sure. Move the, okay, this is to adjust the angle if you need to. Basically what it's telling you to do to clock the wires so that they're coming out the right way. Then mount it. We've got the end stop that needs to go back in with a pair of M3 by 6 cap head screws. And that's going to go in such a way that the connector facing up. So we'll go ahead, and this is going to go on these 2 ears here. We'll just get that lined up and get that screwed back in. Lined up. This. That is making some noises I really don't want it to make. Because it's either cross-threading or not lined up front to back with that screw. So try that again. Now that's still making a cross-threading noise. Do not like. This somehow held up or not great. Me my So it might be that somehow this screw is not, yeah, that is not going in straight there. Most likely that the screw is not being screwed in straight. That's true. Okay, so that was just not getting screwed in straight. Try that again. Now, why did you go in nicely once? Anchor it. Okay, got it. So we got that there. The other thing we need to do before I forget real fast is we need to put this plate back on. once again, there's some like print in place depressions here and up here. That is for the screws and for the EBB 42 board stand to sit on. So you want the flush side to be sitting flush on top here, and your M3 by 35 cap head screws will go through this, through the plate, through the fan, and into the bottom of your fan shroud. There we go. So I think we're all caught back up again. Our 4010 fan going in the front. And directionality. They provided new shrouds, I think. Yes, they did. I don't think they're different from one another. Maybe they are. Nope, they're exactly the same. So I'm just going to keep the one from the original. These are going to get installed with M3 by 16 cap head screws from the front. And the wires should be positioned where the arrow points. So the wires are coming out at the top right. Just kind of get these lined up. We'll throw one of the screws through the faceplate and the fan. Once again, you want the sticker on the fan to be facing the direction that you want the airflow to go. In this case, back towards our hot end. Get that screwed in a little bit so it doesn't run anywhere. Grab the other 3 screws and get this screwed on to all 4 corners. Okay. Now it wants us to mount the beacon low profile to the, Now install the beacon. This is easier done if you don't have a build plate in the way. That's, can I take the build plate off? Should be able to. So what I want to do is put this free. Get our cable free. So that over there, we need to put our beacon probe. So our beacon probe is going up underneath here, which means my bed's in the way. I'm not going to be able to install it there with the bed the way it is. Now the bed can be removed. The downside is hopefully we can just set it right like that because we've got the wires back here. So setting it like that, we should be good. Should be out of the way. We won't have any issues. Trying to find my other belt wiper pads. Probably got knocked down on the ground somewhere. Okay, so we need to install our beacon up underneath here with the M3x6 countersunk low head screws. So these are not countersunk, these are tiny flathead screws. Darn it. There we go. So they're flathead, not countersunk. And it goes on. Which way? Which way does this go on? So the connector side is facing up. So it mounts just like this up underneath our tool head here. And what I'll do on the next one is we'll actually install this before we install that shroud so you can see this a little bit better. It's probably going to be easier for me to also install that wire at this point. Searching for the head of the screw. And that's good. Awesome. So, tool head one, getting a lot closer. We now have a beacon installed. All right, sounds good. Speaking of coffee, drink it if you got it. Drink it if you got it. Take care not to over tighten the M3/6 screws as you can damage the PCB and the printed parts. Yes. Now it wants us to install the Orbiter V2 to the machine, and that's where we're going to deviate slightly. Once again, we had the original Orbiter 2 that was on this. The plan is we're going to install the 2.5 that came with the kit, and we'll get this installed instead of the original 2.0. The difference is primarily in the extruder gears, the RNC coated extruder gears themselves. Yeah. So two 2.5. So not much looks different. The front looks a little bit different, but same type of motor and everything in the back. Yeah, and we have to remove the tension arm screw. And what we're going to do is right now, the wire's coming out this side. What we need to do is take this out, rotate it 180 degrees, and put it back in. So in order to do that, we have to be able to flip this arm down to get to the one screw. We have to be able to flip this arm down to get to this screw. And so we need to take these two screws out so that we can take this motor and flip it 180 degrees. So that's what we're getting ready to do. Now we've got the motor wire coming up to the top. And let me show you that difference once more. So Orbiter 2.0, Orbiter 2.5. We're running, this is the 2.5 here, this is the 2.0 here. So we're running hardened gears. So a good indicator. Okay, so I'll go ahead and put the latch back on or leave the latch off. Reinstall the stepper motor. Install the front screws and install the tensioning. Okay. Reinstall the tensioning screw. And I'll probably cry in half a second because what we're going to do, pulling you guys back around here. Sorry, overconfident. We're going to sidestep for a moment and come down here to our upgrades. Let me go full screen again. So we're going to come down to the upgrades and you're going to see the Orbiter V2 Smart Sensor. I'm going to right click on that and open it up over here in a link. See what we're going to be adding in. Now we've got the Smart Sensor. This is a brand new design, much improved compared to the previous sensor version. Filament auto load, filament tangle detection, runout sensing, blah, blah, blah. Has different color lights. So red, no filament detected. Green, filament is present. Blue, blinking, filament unload. Yellow, blinking, filament is tangled. You have a build guide here. You need the Orbiter 2 Smart Sensor, an M325 button head screw included in the Orbiter 2 Smart Sensor box, an M3 washer included in the Smart Sensor box, and an M3x16 hex spacer. I have no idea what the size of this hex spacer is. The one that came with the kit's a 20. We need a 16, so I need something that's 4 millimeters shorter. Oofda. Let me see if I've got a different spacer. Otherwise, we might have to hold off on these. Because I did not buy these from whatchamacallit, these might be stuck and need to find some 16. Yeah, those are 20s as well. Yeah. I feel that I have spacers somewhere. Question is where? Not there. Oof, over here making a mess. Okay, not there. How about here? If not right here, then I may need to hold off on doing that install, because it just means that they're just not going to be readily visible or available. Size, oh, these are just, no, these are standard standoff Raspberry work. Evil Diesel back yet? Okay. We'll keep going. We'll have to retrofit this because I forgot I'm going to need those 16 millimeter standoffs to do the orbiter sensor. Hey, Shenanigans, how's it going, my friend? Welcome on in. Welcome on in. So we are looking to, and while we're doing our upgrades here, the plan was going to be to install the orbiter smart filament sensors on our orbiters. The problem that we're going to run into is the words on stream, of course. I need a different size spacer. The spacers we have are 20 millimeters, and I need 16 millimeters. If I had bought the kit, well, you know what? Hold on. Just for giggles, let me actually look through all of the parts that they had provided in the kit. They provide the M3x20. They don't provide the M3x16. So because I did not get my smart orbiter sensors from RatRig, I'm getting the standard 20 millimeter spacers, which would be not installing these sensors. And I did that because I picked these up from KB3D that were local. So we're going to have to put this back in the box, and I'll have to install these after the fact. Once I get the spacers, either Evil Diesel will have some, or I can find some, but I'm not going to take the time right now to root around in the closet of death back there that has way too many spare parts. I know I have spacers. I just don't know if I have 16 millimeter spacers. Welcome in, Cruising Girl, Retro Maker TV. Welcome, welcome. So we're going to have to hold off on the smart sensor upgrades. So we're going to come back here. We got everything put back together. We're going to mount this now with two M3x8 cap head screws. One, other one. Yep. So two M3x8 cap head screws are going to get mounted on top of our PTFE tube. Let me twirl you back around here. Check the camera. Switch the camera view. Oh. I need 16 millimeter versions of this M3. M3 on both sides. 16 millimeter. All I have are 20s. Or at least all I can find right now are 20s without digging around and rooting around in a bunch of crud in the other room. Or in the other room, in the closet. So the PTFE tube is going to go into this metal piece right here. Get that close, get it lined up. And it'll slide right down on there. M3x8s, one on each side. Yeah, 16 millimeter long M3 hex standoffs. Well, they don't even have to be hexes. Get it nice and tight. Give it a little jiggle jiggle. It is. It's 3 millimeter threaded on each end, so it's like a barrel hex spacer. I have some standoffs that have a thread on one side, but they're like M2.5 because they're made for Raspberry Pis. So those were the ones I found quickly. I have a whole bag of, rather than being the hex shape, they're knurled cylinders, but they're also 20 millimeters long, which means they're useless. Take care not to over tighten the M3s, as you can strip the tool head plate threads. We didn't do that. Thread the hex standoff on the orbiter 2. So this is the one that's going to get threaded onto the top right. We're just going to do the 3 threads that are showing. I'm going to thread that on there. And if you're adding the sensor, then it kind of sticks out a little bit more, and that's why you need a shorter spacer to space your tool head board out. Hey, Lucas Player 1912, how's it going? Welcome in, Giggy Jack. And Hey Bit Nuts, how's it going? So now it's going to tell us to set up, and we're going to install our tool head board. Yep, tool head board installed. We'll need to connect a few things up, like our fan wire. This will be the end stop. We'll need to reconnect in our wires for our hot end and thermistor. So let's work on getting those back in. other. So Hotend power wires are installed now. Not the way. There we go. Hotend power wires are installed. Next up, we need to get the install on the tool board, add a bunch of things in. I'm going to hold off just for a minute on installing that because I need to get the wiring done. And it's not going to, of course not. EBB 36. This goes to the end stop. This goes to the motor over here. This is the fan connection, which will go there. Direction, pins go in a lot easier. This is the other fan. So fan, the other fan was right next to it, I think. And then the thermistor is above, right? Let me double check those two right quick. I'm just trying to figure out where each goes on the EBB 36. Or excuse me, EBB 42. EBB 42 can board. Yes, sirree. That is a 2209. One or one dot. I don't think it'll. Um, pin out. 42 hardware. Really, all I need to do is thermistors at the top so the fans are side by side. That's all I really needed. So this fan, that goes there. Thermistor is going to come up, come around, and go into the top there. Fan's going to come around and go back. What I'm trying to do here is just get things lined up and back in their spot so that it makes it, because this is a retrofit. Why? I'm trying to use a ball end driver to tighten an M3 screw. There, right along there. This will come around, go like that. And this is going to come around and go into the motor right there, where my locking at. Flip the connector. Sorry if I'm blocking the view. So it looks like everything is connected back in. Now we'll just need to do some zip ties to tidy a couple of things up. And of course, follow the guide. So that IDEX is complete. I am going to grab some zip ties and zip tie that stuff up so that it is tidied up. And when we go to do the second one, we'll have to really tidy a lot of things. Well, we'll have to do all the electrical wiring and stuff when we do that one. How are we doing this? 120? Okay. So one on this side. Fun ones are going to be the ones at the bottom for the USB cable for the whatchamacallit, the beacon probe. Most part, this is just putting these back in where they were before. And for the most part, the ones over here on the side are just keeping the wires tidy side to side. Ones in the top up here will be a little bit more fun to do. All right, so we got those two. This side, there's a provision right here for a zip tie. Small channels. There's one of these I was doing on another printer, and I actually snapped, or no, it was on a box turtle. I snapped the zip tie, just trying to get the zip tie through the slot that was designed for it, which was wonderful. So that goes there. I think what I may have done in the past is routed these wires behind the board. Let me see if I can get them there now. See if I can get them there. Come on. Almost. Come on. There we go. Route it behind the end stop board rather than in the little groove just in front of it. The wires are out of the way. Route it up and behind there. This end, that way there's no chance of that wire getting to the front and pinched or anything. Wire's going to be good there. We can get our end stop. The only other wire that I really need to do underneath is the one for the whatchamacallit, the USB cable here. I think that comes around and comes up like that. And gets zip tied right there. Might call for one of the thicker zip ties. Let me grab a couple of those. Hey, Lucas Player, how's it going? Yeah, it's been a little while, hasn't it? Nylon would work too. I just need one. I just don't have one. But yeah, nylon should work as well. That goes there, and I thought there was one on the bottom as well, or the back here. The back, there we go. So one here, one in the back. Now I'll keep that wire nice and tight. Sorry about getting my big bald head in the way there. So wire tighty. We'd be able to get our PTFE tube back down in there. Of course, after we take the clip out, it always works easier that way. Clip out, tube in, flip back in. And that works for now. We can add filament runout, like I said, a little bit later. Not that big of a deal. We do need to add our zip ties in here at the top. And we also, before I forget, need to add our other M3x35 screws at the top, because that's what's giving it some of its rigidity. Because these screws go through this base and gets it back down to the metal plate and holds this in place. Can't tell if things are lined up or not. There it is. This one down here. Like this is not lined up appropriately. Yep, that's not lining up. So we'll have to work on that one. Hmm. Like it's right there, but it's not lining up somehow. Hmm. Aye, aye. What is on? I wonder. Give me the screw back. And just double check. Yeah, that's 35. I don't think it's over tightened because I never felt it tighten up. I was debating whether or not it was even in, like, made the screw hole. Yeah, so that one's in. This one just never feels like it's getting in. The screw hole or lining up at all. We're going to call it and say it's in there because I can't get it to come back out right now. Maybe I'll play with that a little bit more after the stream just to see what the dealio is. Because if it winds up being a loose screw, it will mess up your thingamabobbers, your input shaping. So yeah, brass or nylon would work. The ones that are coming with the kit are, I don't know if they're aluminum or what, but they're not very, you know, they're not like stainless steel or anything like that. Okay. Remember right. There. No, there isn't. Okay, so these are just like wraparound wires, and what I'm doing is lining them up with the groove and giving them a good crank down here. Once again, just making sure that they're staying lined up in a groove. You got 4 grooves, so you're going to be able to do 4 of these. And I am, the first 2, I'm bypassing the power wires because I don't want to kink them over that much, right? I don't want to kink these over to try and get these 2 because this one's literally right at the top of the connector. So I don't want to do that. So 2 will go around everything at the back except for the power cables, and then the 2 top ones will grab everything. Snip those off. And we'll call that tool head done for now. And we'll be on to the next tool head. So slide this over out of the way. Bring our other carriage over. Now we're going to start with some coffee. Hey, thank you for the follow, Servo. And welcome in, Nova Games. How's it going? I'm doing good. We're having fun. We're putting some things together. We're going to need our other tool head plate that came with our IDEX kit. Flat on one side has a bunch of countersunk holes on the other, so let's just assume that the that the flat side goes flat, and that the side for the countersunk is where our holes are, or our screws are going to go through. We're going to line this up and screw this on. Now I'm not going to tighten any of these down. I'm just going to get all 4 screws starting. And this is a working printer that we are converting from the hybrid setup, single tool head, to a IDEX. So that would be why we've got one tool head fully wired and stuff, and the other we're building from scratch and there's no wiring in place for it. Because we're going to literally be doing our wiring for this tool head as we build it. So you kind of want to tighten these down a little bit at a time in a crossing pattern, and it's going to help self-align this plate front to back. And now these screws had Loctite on them, so you don't need to give them all the ugga-duggas. You just need a little bit of ugga-dugga on there. This is going on the second linear rail carriage, the one on the right, the one that we added as part of this. It was great. We started off, we had to tear this entire tool head down because a lot of the printed parts are going to be different. And we also needed to take the rail off and add our second carriage back on. So after tightening the screws, it's essential to verify the X carriage retains its free movement. Yep. I'd say they are retaining their free movement. So we're good there. We're going to put our other piece together, which we've already got assembled. Remember, because we assembled it and we originally had it on this one, then realized, oops. Now, one thing that I am going to do is look in here, or do I get a second beacon scanner? Looks like I do. Maybe not. Is it just the one beacon scanner? Because the last thing I want to do is go through and put everything in there and then go, oh, add another scanner to the bottom, which is doable. It's just painful. So far, I'm not seeing a beacon scanner. Just the one scanner, and then we're using, okay, it looks like just one scanner, and then we'll use the Z offset thing to make sure that they're both the same height. Okay. Join the two assemblies together with M3 by 16 from the back, M3 by 8 from the front. We did that. We need the other cooling fan. Grab that. Cooling fan. How do I have a? Okay. So we have a cooling fan. Seems like it's a lot longer, and we're going to have to be cutting and redoing that wire. But anyhow, we'll get there. So have cooling fan. Remove the rubber spacers. Yep. we got to remove the little rubber spacer pieces from there. 3, 4, only on the one side, so we'll remove those and get them out of there. Get these parts ready. So we'll have the front shroud piece. Sorry, shroud, fan grill piece. Yep. Some screws. We need an M4 by 10, 3 M3 by 35 cap heads, where's the M3? 3 of these, 2 M3 by 40 countersunks, okay, and that piece. Yes. Okay. Now install the rear component and the duct subassembly into the tool plate. Ensure the belt connected to toolhead 0 is properly positioned and remains clear of toolhead 1. Take special care to avoid pinching or damaging the T0 belt. During the installation, put in the part cooling fan. Airflow should be directing down. Yes. Point the fan wires to this side, that side being towards the other tool head. So directionality, where the sticker is, that's the side the air is coming out of. So we want the airflow down there. Now, do I want this? Yes, and I want the fan wire coming out right here. And we need to make sure that when we put this in, that the belt from the first one, which is the top belt, is riding right in this groove and is not being pinched by anything. Should be fine to do that. Then we're going to use 2 M3 by 35 countersunk screws. M3 by 35 countersunk heads. 3 by 35 counter. The issue, they tell me to get all this stuff out and then they call out for different screws when we go to install this. We're going to take this piece here. I've got the fan sitting on it. I'm going to set it at the back and basically slide it forward underneath there, making sure that my belt is not being pinched. There we go. Slide it right up at the top there, slide it forward. That belt is not getting pinched. M3 by 35s and the forward two fan holes. 2mm driver. Okay, once again, run this and make sure that it's not pinching that belt, which it's not. Okay, next up, we're going to slide in the front fan shroud, and we're going to use two of the M3 by 40 countersunk screws. This is going to slide in directly from the front, and you'll see that both of our tabs are on the right-hand side now, where this one was on the left. So we'll have an end stop here, and this will have the end stop on the outer edge. This slides in, and these will go in on either side of the offset 4 screws for our tool head. These down in there. There we go. Once again, take care not to over tighten the screws, as you can damage the print head. And don't use a ball-headed hex key for that. Now we're going to take the rear fan grill and a pair of M335 cap screws. Once again, there's a flat edge and an edge that has a depression up at the front and some spots where the heads of the bolts will go. That lays right down there. These are going to go through the fan at the back. I'm going to try and make sure that they're lining up with the holes some, because it could very well be that the reason this isn't lining up is the rear piece here might be shifted a bit. Yeah, that's just turning. Still don't know why it's doing it. I'll have to play with that after stream. Okay. Again, take care not to over tighten, as you can damage things. Next is we're going to insert the belt in the designated slot. So this is going up here at the front, and we want it to go inside the groove, which means it needs to go around the screw. So what we're going to do is we're going to take this belt, we're going to bend it like that. I'm going to pull the screw out, put the belt in, then put the screw back down in there. It's a lot easier, especially since the belt is, in essence, pre-bent like this. And I want the easy button. Pull the screw out, slide the belt in the groove there. Put the belt in the groove. Put the screw down. Belt did not go in there the way I wanted it. There we go. Now we can tighten the screw back down, and the belt is now going around the screw miraculously. I'm going to pull this forward so that it's pretty much in line with the depression in this side piece here, because that will set my belt up for the next piece, which is to take the belt clamp here, and we're going to push it in and kind of rotate it forward, and it's going to lock in on the teeth of that belt. And that will hold that belt in place and keep it from coming out, especially once we get the screw locked in here. Screw locked in there. And that belt naturally lines up with the teeth. Feels like that belt slipped out some. Did by a lot. Oh, good thing I have extras because I just cracked that part. Because I cinched it in way too hard. We'll pull that out. Crack that. The reason I have extras is I have the original ones that I pulled out, and then I've got the new ones that came in the kit. So that's why I have extra printed parts here. So once again, absolutely no need to ugga-dugga the life out of this. The teeth are lining up with the belt, and that's what's going to give you your grip to hold your belts in. No need to really ugga-dugga on these. Or a belt taunt. Okay, next up, we're probably going to do that lower belt. Okay, here's the, put it in, rotate it forward, put in your M4x10 countersunk screw. And on the back side, feed the belt through the hole in the rear of T0. The belt is correctly seated on all idlers. It should be. Hasn't gone anywhere. So we need to take this and slide it through the channel at the bottom of T0. We can slide this over out of the way, bring this one through, and make sure I get it into the slot in the printed part. And it should come all the way through. Yep. We'll take our This will be the next step. So we're going to take this piece, put it in from this side while pushing our belt through. And what this piece is ultimately going to do is be pulled in by an M3 by 35 screw coming from the left side, and it's going to squish that belt forward into the back of the printed part. This there. I'll crank on this for days because this is a 35 millimeter screw going through plastic parts and all that good jazz. So in essence, the way this is designed, your belts are going to be a little floppy at this point. Partially because my belts have already been cut after they were tensioned. But I'm running the belt this way, and then I'm pulling apart this way that's going to squish it forward, which means a little bit of it's going to pull back out as it's tightening up. But that's why we've got tensioners. Thank you all for hanging in there with me. I know I haven't been able to look and be as interactive in chat because this setup is different than normal. Normally I'm able to look straight ahead and see chat, but working on this printer where it was needed because I can't lift this printer and move it by myself. This is snugging in. And I'm moving this and I'm not seeing this upper belt, which is for toolhead 1. Nothing's moving there. And as I move toolhead 1, I'm not seeing any issues with the other toolhead. Okay, there we are. What's up next? So we've got that tightened. Cut the excess belt. Gotcha. Now we're going to set up the other Fadus Rapido. This is the new in the box one that just arrived with part of the kit. Now there are other hot end options rather than just the Fadus. I know that Luke's Lab now has a tube toolhead set up for this, so you could do a full up tube if you wanted to. You can, I'm sure, get a Next G to work in this setup as well. It's just whatever you want it to do. Me wires. Give me wires, thank you. Okay, just looking at what's all on the kit here and what I'm going to need. We've got thermistor and hot end wires. Chances are these might be good enough. They might not be. We've got the standard and the ultra high flow glove. I want to say I'm running ultra high flow. Not even think about that. I'll have to pop this up there and see if I'm running ultra high flow or not. A little key here, try and get the you've got to take these two tiny screws out in order to get your basically your groove mount or your V6 mount off. And of course, these are gooped on there, so nice and tight. Won't need those for this application. No, those are off. And this gets installed. Remove the two countersunk screws in the top of the Rapido. Yep, did that. This has a 0.4 nozzle and then 0.4 or 0.6. Awesome. So 0.6 hardened nozzle or 0.4 standard nozzle. We'll be using a 0.6, so we'll have 0.6 all the way around. Keep all of the extra accoutrements. You never know when you're going to need them. BTFE tube would come in the kit. Blah, blah, blah. Take that off. Refer to the steps in the previous section to make sure that it is positioned correctly. We want the wires to be coming out the left side still. And if we that's almost perfectly clocked, so we're good. If anything, I want to turn that zip tie around a little bit so it'll be out of the way. We need our M4 by or 2.5 by 6 countersunk screws. They're in the kit. And there is no Loctite on these. And I'm not going to put Loctite on these since I'll say burned one of the ones I installed previously. Or meaning when I was trying to take these out, I had stripped the head out of one of them. Before I go and do that mistake, I'm going to pop this sock off, add on the extension, get to my longer whatchamacallit, give a crank on that. We'll also do a pre-crank on that nozzle. We'll have to heat tighten both of those. So I will leave the sock off for now, but we're going to put this back in there. One, other 3 done. So how's everybody doing today? Everybody having a good Saturday morning? I hope you are. I don't know who's hanging out here and who's over watching the Lee Marie channel or anybody else that's streaming today. Okay. Slightest ugga-dugga here. So we don't burn out those screws. Wants us to install the end stop next. So this is another one of our really nice Omron end stops. And M3 by 6 cap head screws. Profile, hobbies, M3 by 6. So once again, this is coming in from the right side, from this side here, that over, and it's one screw into the side of the back fan shroud, the other one's into the front fan shroud. Make sure to leave them loose until you get your screws started. And this is one where to get the straight shot, you may need to use your ball end driver. Otherwise, you'll start to either gouge up your rail or cross thread your heat set insert, neither of which is going to lead to a fun experience. Now that's installed. Fan shroud. We've got our front fan. Once again, the the sticker is the side that the air is going to go out of. This is a 24-volt fan. That's an interesting change. No, yeah, these are 24-volt fans. The rear fan here, the PWM will go into the board, and then the power for it runs all the way back because they're 12-volt fans. Okay, so we need a fan, a shroud, and M3x16 bolts. Here's two M3x16s. Do I need to? I'm going to need to add a couple of M3x16s to it. Not a problem. We can easily do that. Sorry, I'm mumbling to myself as I'm trying to put up the stuff that I'm not going to need for the hot end. I'm going to have two of the four M3x16s. So I'll need to add a little bit to that, which is not a problem. Like I said, I know I've got a big bag of parts available. So, and by big bag of parts, I do mean a big bag of excess parts from when I built the machine originally. So I can either dig in there or grab some out of my bin, which will probably be easier to find. We'll just grab two from here. Okay. So the fan goes on, and which side does the wires? Bottom left. Okay. The bottom left like that. We'll have a fan shroud cover piece. There are sacrificial layers here that we need to poke out. So we're just going to poke those out. Simple thing, take your driver, push it through. Sacrificial layers are now broken out. You can run it through the other way as well to try and fully knock those pieces out. Get them out of the way. Be good. I'm going to grab one of these, one of these, one of these. Once again, our wires coming out at the lower left. Get that lined up. Getting that installed, grab the other three screws and get the rest going. We're watching a bunch of stuff split screen. Yep. Thanks for the follow, Estuary. Welcome in. Yeah. Whoops. Here we go. What is going on there? So we are installing the second tool head, so the IDEX upgrade for our RatRig. And so one of the main differences is when you have just the single tool head, both your lower and upper belts are going to the same tool head, which means you're engaging both of the lower motors for an XY movement, and you've got the extra Ys up here for the hybrid. Now what you're doing is you're using one belt, so the upper belt for the left tool head, the lower belt for the right tool head to control the X movement, and your Y is controlled up here by your hybrid motors. So I've heard people say that their input shaper graphs suffer. I don't know if that's going to be the case. Also, as we discussed before, I don't think it's really going to matter for me because I'm not going to run it full tilt, right? Snack time real fast. Okay, so this is where we would install the orbiter. Let me check real fast and see if by hook or by crook anything actually showed up today. And no, it still says Monday for the hmm. Yeah, so nothing is showing as arrived yet. Just double, triple checking. Yeah, so nothing's arrived yet. So I don't have the Orbiter 2.5 now to put on this side. If I need to, I'll set the 2.0 on there to mock it up. And then I'll have to swap that out when the 2.5 gets here. It says Monday. Hopefully it gets there beforehand. Mount that. We do have a pre-made piece of PTFE tube. Now, my suggestion, only my suggestion, would be to chamfer this on both ends. It doesn't call it out. And I will tell you that the one thing that I run into, the one thing I dislike about the Orbiter toolhead is the metal tube on the inside. While it provides a highly constrained, so you got the metal liner and the metal tube that's down in here. Well, the problem that I have is if you get a big bulge at the bottom of that filament, it can catch and solidify at that tube. And now you've got it stuck inside this tube. The only way you're going to get it out is basically take your orbiter off and do some manual intervention. That's the only issue that I have ever had with an orbiter. So we need to take our PTFE tube. I am going to take my Capricorn tubes poker here and just lightly chamfer both ends of this tube. That will just help with any bulge going down into your tool head or coming back up. But once again, it's going to be internal to the orbiter where you may have an issue where it'll hang up. So just something to be aware of. So tubes in there, it's going to tell me to mount the orbiter. It's going to tell me to do the spacer. And then we're going to start building the back panel here. So I'll bring it over here to the bench. Way too far. There we are. So this is a EBB 42 CAN bus board version 1.2. We get, once again, all the vittles for that. That needed to go back in here. So we need our board. We're gonna have to not sure if we'll need that. Root around in here and get the heat thing, the heat sink out. We may need some of these. I can't remember if they provide pre-made cables over there or not. So for now, I'm just going to dig out the heat sink, and we'll dig more into that if we need it. Move the adhesive backing from the heat sink and install it on the 2209 driver, which is that chip right there. Put this on there. Make sure we're not blocking any of our little jumper spots down here in case we need to use any of those. Now, here's a fun thing. This needs to be flashed. I have a feeling it's going to tell us to go ahead and install everything, and we won't have this flashed with our motherboard. Thinking. Yeah, we might have, we'll be able to do this because one way or the other, we'll be using the USB cable. What we can do is jumper this center one here for 5 volt. We'll have to push some of our buttons and flash this board. Be a lot easier to do it off the printer, but trying to think. I'm not 100% sure. We're just going to roll it. We'll cross that particular bridge when we come to it. So I think what I'm going to do for now is I'm going to grab the spacer, if I can find it, threaded spacer. and an M3x8 cap head screw. These are both the same, so it's not going to make a difference. Oy. I'm going to get this in here. Because when I go to do the orbiter, is pretty much I can remove the, yeah, I can do everything on the orbiter side of the equation when I go to swap in the filament runout sensor and stuff. Basically, I'm just going to run that screw all the way in, and then I'm going to take this and flush it up to it. We're going to take two M3x35 screws and run them from the top down. M3x35. This is the two where I had the one trying to come down from the top here was a pain in the butt. So how are we going to do that? Well, we're going to run it right down there like that to get it started with. Make sure it's pushing out through the bottom. Like so. Then I'll make sure that lines up. Get that one started. Sorry. Trying to get this one down in there. Now I got both of these started. Run for days. All right, that one tightened up. That one tightened up. Now here's what I'm going to do is, look how much space I have there. I'm going to go down on this screw head. So my screw is not even all the way down. How am I catching on? I'm not even getting. Okay. So this screw is all the way down there. There is something fouling that I can't even get my. You know what? So I'm driving a screw into an existing screw. That is my problem. I am basically trying to screw a screw into the top of another screw. I'm an idiot. Yes, I am. Yes, I am. Wait, screws magnetized? Okay. So it screws in better when you're not trying to screw another screw into the top of that screw. Yeah. So, okay, that's done. This is now firmly in there. This is now firmly on there. They're not over tightened. We're not going to damage anything. Now it wants us to use 4 M3x8 cap head screws to mount our board onto the tool head. So we've got 4 of our M3x8 screws. And you want this screwed in so that your white connector is facing up. Once again, you're just tightening down a PCB. It does not need to be, a huge ugga-dugga here. You're just making sure that your PCB is not going to go flying off anywhere. You also don't want to squish and crack or break your PCB because that could lead to a bad day as well. Okay, PCB installed. What's up next? Skip this step if you're just upgrading your V-Core 4 hybrid to IDEX. Yep, skipping that step. Continue to the next guide, toolhead wiring. Awesome. We're on to toolhead wiring. Cut the wires with 150 millimeters and strip 10 millimeters of each end to expose the inside conductor. Cut the thermistor wire with 160 millimeter and crimp a 2-pin JST connector. Awesome. I'm going to take that back out and we're going to do that on the workbench where it's going to be easier to measure, cut, and do everything without it being sitting up here on the printer. Because I do not know why you would tell me to do that after I've installed it on the printer. It would make sense if you want me to cut these wires, you would tell me to cut them and do it on the workbench. Same thing with the fans, because it would make life so much easier than doing it on the printer itself. So it wants me to cut these to a specific length. We'll be able to measure that out here on the workbench and get those cut to the right length. And that length is 150 millimeters for the hot end. Okay. 150 for the hot end and meter 24 volts. So that's the one we're going to do. We're going to lay the fadus right there, come out to the 150 mark. That's where we'll cut it. Let's see if we can get this pulled down. We can. We're going to cut this. And strip 5 to 10 millimeters of the end to expose the inside conductor. Because we're going to crimp some ferrules onto it. I just hate trying to strip this FEP style wire. Okay, so we got those ready to go. The thermistor wire is cut to 160. Barely cut it all. And we're going to change these over to JST wires. And if you got the tools and you want to, you can dig these out. These are microfit connectors. Pretty good. Their microfits are higher amperage than JST. So if you have the ability to, might not be a bad idea to recover those. They're also a little bit more expensive than a JST connector is as well. Okay, so this one's going to get a 2-pin JST connector. And it may have given us some stuff, but hey, there's stuff in here as well. So see what we got. 2-pin JST, and we got 2 different size JST connectors here. I think these are the standard JSTs. Two-pin JST. Larger size here. And like I said, I have a feeling we're going to have to cut and repen our fan. So on these, you definitely don't need as much stripped. Grab our IWIS or iCrimp IWIS IWS 2820Ms. These are the crimpers that I've been using. A lot of people use PA09s. I've been using these based on a recommendation by Steve Builds. And I like them so much that I bought a new pair and gave my old pair to Evil Diesel, who's been doing crimps with a pair of needle nose pliers. Surprised he hasn't burned things down with that. Oh wait, we do burn up a bunch of ESCs in our death racers. I don't know if he's listening in still. I was trying to get a rise out of him there, but I don't think I'm going to. There is no polarity on either one of these wires, so it really does not matter in which order you put them. Okay. Move that back down. By the way, this is a PT1000, so we'll need to know that. Our heater wires here. What's it going to tell me to do? Insert the cable ends on the designated slots and tighten the screws. No, sir. I am not sticking bare wire in there. Not going to happen. So 1 second. We're going to grab the ferrule kit. Ugh. We're going to use the 22 gauge ferrules on this because if we don't, they're probably not going to make it into the connectors. Spin your ferrule on there, crimp it down, gives you a nice ferruled crimp. And your wires together for the other one. Grab your ferrule connector. I find kind of spinning it with the wires will help to screw it down onto the wire, get it lined up easier. Crimp that. Normally I just take the number that I need out and close this up because my biggest fear is knocking that off the workbench. I haven't done it yet, but I have no doubt that it is coming someday. Not a doubt. Okay. Set this back aside. Okay, so we've got ferrules and we've got our JSTs. I'm going to be quite honest with you. I'm going to pull that board and we're at least going to put the ferrule connectors in for the hot end. Just because placement wise, you're not getting it in any other way. Yeah, due to the size and the placement of these, there's just not an easy way of getting the angle to get these in. Once again, there's no polarity here. It's just a big resistor. Now, putting that in, you'll see that there's a gap there. So what I will do, safety squints and put your finger over the edge, but we've got these little grooves in here. I'm going to line up on the outermost groove, put my finger over the top so it doesn't go flying, and snip the outermost groove. Now you can see the difference in size there. That's all I'm going to need to make it so that the connector is fully seated inside the screw down terminal, and therefore less of a chance of any type of arcing between these two connectors where there's exposed wire or conductor. So get both of these shoved in there and get this screwed down. I'll show you what I mean. So you see how there is no play, or there's no wire or ferrule showing between the screw down connector and the insulated covers. That's what we're looking for right there. Then we might as well take our thermistor and plug it in right there. Okay. And I want to double check something. Can't. So we've got these two pieces tied into that board. We're going to take and mount this back up in the printer. We're going to get this mounted back up into the printer, and then we'll kind of loop that board up and around 1.5. And so once again, the reason I did that is to push those screw down connectors from the back when they're sitting like this down at the bottom. You're not going to be able to get them in there that easy. So it's just easier to do it this way right now. Okay. Now, what's next? Route the wires up behind an end stop and connect them in. So these are coming out the left side. They're not going to be going around an end stop because the end stop doesn't exist on the, well, it's over on the other side. So these are going to come up. There's a zip tie point right there, and there's a zip tie point on that edge. So it's going to basically zip tie, come around and plug in. I'm going to leave this like this for the time being because we're going to have to do some other work on fans. So I just want to make sure it's easier to see and get to before we do anything. We will route in a minute. Yes, once again, there's the thermistor wire. Now, there is a jumper right next to that thermistor wire. That's the critical piece. So we have to insert the highlighted jumper to achieve accurate temperature readings. And this is for the PT1000. Normally, there's like some dip switches right here, but they've changed the design so that now with just a jumper that I could not seem to hit the wires with, we can set this for PT1000. So here's our thermistor. Right next to it, there's two vertical jumpers. And then right across the top, there's two vertical jumpers. We want the two that are horizontal. It's the two vertical ones that we want to put a jumper on. So we've got that. We've got the hot end and the thermistor end. The orbiter, of course, is going to plug into the motor wires there. We'll be able to reach around just like we did this one, no problem. So we'll worry about that when we get our other orbiter in. The hot end fan is the 2-pin closest to our screw down terminals. So our hot end fan, which is coming up this same direction, will go in there. And once again, all of these wires are going to be zip tied right like that. So we're good there. Next up, this will be the fun one. The cable connector for the end stop, which I believe they did provide that wire for us. We're at there it is. And they do provide JST cables and stuff if we have to redo anything. This is the 3-pin wire that they're giving us for our end stop. It is 3-pin to a 5-pin micro JST 5 pins provided with the EBB tool board. That would be where I was talking about the smaller pens. Yeah. They're not too small, but they're annoyingly small. They're not as bad as the, was it like the PH on the EBB or the SB2209, but they still kind of, these are still small enough to kind of suck. So what we're going to do is we're just going to go ahead and crimp these on the 3 wires, and then we'll get the 3 wires put in the appropriate connector. Like I said, comes with the EBB 42. Now where I was using the 1.3 or the third to crimp the wire, and then 1.5 or 1.5 to crimp around the insulator for a standard JST. For these, you're going to go to the second one, or 1.0 on the crimp around the wire, and the 1.3 on the insulation. And you go, but the wire's the same size. Yes, the connector's smaller, the wire's the same size, and if you don't use the smaller crimps, it's not going to go in the connector, the physical plastic housing connector. So yes, you do have to crimp it, and kind of feels almost like you're over crimping a bit. So and we're on the third one. And I'm going to wind up having to call the stream soon because my left hip's killing me. Standing up so. So we'll get this one done. We'll get it, I'll say, plumbed and connected. Dang it. And that's the fear with these, is if you screw them up just a little bit, you basically cut the wire. And now I'm going to have one of these that's going to be a little bit shorter than the rest because I'm going to have to re-crimp it. But that's okay. Almost 3 for 3 on these tiny suckers. I can live with 2 out of 3 for a start. Three for 3. Now, I need to set this up so that on a 5-pin, it's kind of hard to see, but you've got the locking pin on this side. You want the locking pin on this side the same, going in the same direction, or facing the same face. So yellow at the top. Go in there, you. Hey, Chewy, how's it going? Why is this going to be difficult? Why wouldn't it be? And once again, this is the wire gauge thing. I'm going to have to very gently assist it along because these wires are a little bit too thick. You'd almost be better off using the next size down wire gauge and completely remaking this. So black to the next one. Yep, that one came right off as well. Dang it. I may wind up redoing these with some pH wire out of the SB2209. Either that or grabbing the cable out of 24 gauge FET wire. Because this is like a 24 gauge silicone wire, so it's a little bit thicker. And that's the issues. The first part's going in, it's the part where the insulation's at that's not going in to the housing. And that causes the problem. And then when you crank it down, you basically over crimp it and cut the wire. And get this one to come back out. This one to come back out. Think. Do that and ease that back up in there. No, come on. Why? There it is. Okay. So 3 wires fully seated. Of course, that came from the factory for us. Now these 3 wires are going to go on this 5-pin JST connector over here. So we'll plug this JST connector in. And once again, this is going to come over here to the right-hand side. So we're going to be doing, whoops. So JST connector right here, the 5-pin. This is going to loop around like that, get mounted, and then this is going to come around the right-hand side and plug in. That's kind of how we're going about things right now. So we're almost wired up. Next up, let's see. Can we do what's the next? The fan is next. Yep, there's the in-stop wiring. So the yellow lines up. Yes. So that in-stop wiring will be perfect. Or crimp Molex microfit. Okay, yeah, this is going to be, I think, for the fan. This will be cutting the wire and recrimping for the fan. And folks, I'm going to call it. Let me go ahead and switch the view over here. I'm going to have to call it the back is starting to really yell at me. So I'm going to straighten some things up. I will probably sit down and try and do this connection tomorrow or maybe later tonight if I feel up to it, just so that connection is done and out of the way. It's kind of a pain in the butt, and the simple fact that they didn't have me do it on the bench before installing the fan sucks. All of these wires, if we have to cut and crimp the wires, let me do it on the bench before I install it on the printer, because now in order to get that fan out, I was going to complain, but literally, in order to get that fan out, let me go here. No, this one. I take these two bolts out. This plate can come off because this hasn't been connected. I can pull this plate off. Now I can get to these two bolts, take this plastic cover off. These two bolts, the fan can come out. The fan shroud blower itself will stay in place because of the two front bolts. But I can pull this fan out and then work on this on the bench. So, but still, I'm having to take things apart to make it easier to do. And they need to fix that order of operations on these, I think. But yeah, we'll play around with that next time. Right now, like I said, my back's hurting. So maybe because Mrs. Dragon's not here after I go to breakfast with Evil Diesel in the morning, maybe I jump back on tomorrow for a little bit and we finish wiring up this tool head. If I have to, we'll throw the orbiter 2 in place until we get the 2.5. Not that big of a deal. It'll be an easy swap out. Like I said, it's 3 screws and a JST. So it'll be easy enough to swap out once the other pieces get here. And then we'll also have to do the wiring for the sensors, which we could possibly do that as well. If it gives us the wiring links, we'll do that on the bench before we get the things to install them. I'll go look on Amazon for 16 millimeter long M3 standoffs. So yeah, let me fix my screen here. Try not to trip on the new camera. That would be bad. Don't take out the new camera. Put our lube away. I think we're done this. Just going to chat a minute while I put some things away and just run through my head to see if there's anything else that we need to do or talk about. Like I said, the other major thing is going to be running the electronics to the back. I may see, that's one thing I might do, is see if Evil Diesel can help me tomorrow to rotate this around some so we can get to the back panel, which is up against the window. Because we'll have to run wiring to the back and get things plugged in the back. And we're going to have to flash this board, and I'm going to want to flash that board before we're fully wired up. I say before we're fully wired up, before that board is shoved in place, so I have easier access to the buttons. So yeah, there we go. So with that, let me take a gander to see who is online that we can jump over to. Saturday, let's see. Team Pool, Maker Deck, Painterly Git. Same old Shane, Brillo, Vile Mods, Boxin, Jerry 3D HP. We haven't jumped over to Jerry in a little while. So let's go ahead. We're going to jump over to Jerry. He does a community stream, basically. And so that's kind of cool. Every once in a while, I will log in and hang out, but I think I've been up and running too long, and I'm going to need to sit down and take the proverbial load off. So hit start raid. That always helps. So there we go. Raid is started. Thank you everybody for hanging out with me. Like I said, be on the lookout for another stream tomorrow. As we will, I'm pretty sure tomorrow we will continue doing this. Try and get the final things wired up so that we can start working on updating the firmware and all that good jazz, because that's always fun. No, maybe it might be fun. I don't know. But thanks everybody for being here. Like I said, look for an impromptu stream tomorrow to continue on this. And then hopefully by Tuesday, we're buttoning things up and we can start actually running 2 sets of spools through things and going that way. So thanks everybody for being here. Come with me as we raid on out to Jerry 3D HP. Say hi, hang out, chill and chat for a little while. And I will see you guys next time. Here we go. Bye now. And for those of you that are watching this over on YouTube, thank you for being here. Please, if you have not already, like and subscribe down below. When you subscribe, click on the bell and make sure that you select all so that you can get notified of future stream events. And YouTube is going to offer up a new or another video for you. Thanks all. Have a great day.